So let's take a look now at part F. What is the probability of rolling at most two ones? I want to start by writing out my probability notation. I want the probability of x, the number of times I roll a 1, to be at most 2. So I want to roll a 1 2 times or maybe fewer. Now there's a couple different ways again that I could think about trying to tackle this question. I could think about doing this by looking at my table and grabbing the probabilities that actually are already listed there. So here, the x's that are less than or equal to 2 are 2, 1, and 0. And so I could grab each of those individual probabilities and add them all together. So I could easily just take my 0.421875 plus my other 0.421875 plus my 0.140625 and add all of those up. And I believe if I did add those up, I'd end up with a value like 0.984375. So this is one approach. But of course, it requires that I might have already created a full table and already had each of these three previous probabilities. Now, there's another way that I can compute this probability that is much, much quicker. And this involves using our second calculator command, the binomial CDF. The binomial CDF will calculate the probability of several x values all at once and add them up. But it starts by calculating the probability at 0 and then adding it to the probability of 1 and adding it to the probability of 2 and all the way down until you specify a stopping point. So notice here, since I'm interested in grabbing the probabilities 0 through 2, I could easily tell the binom CDF command that I'm working in a scenario where n is 3, where p is 0.25, and where I'm interested in stopping at the value of 2. Notice that when I do this, if I go to the calculator, what I'll find is that over here, click on my second distributions menu, I go down here and I select my binom CDF, so make sure it's CDF this time, 3, 0.25, and 2, and the number that it gets back for me immediately is going to be my 984375, which you'll notice is exactly the same, 984375, exactly the same value that I had before. So again, the CDF just allows me to quickly calculate a bunch of probabilities and add them all together, but it requires that I'm starting from the bottom value of the table of 0 and then progressing up until a specified stopping point. Okay, let's see. Can I go ahead then and answer something like part G and find maybe the most optimal way to answer this question? Notice here, I want to use the probability distribution that I established up above to determine the probability of rolling, so that's x, rolling at least 2 ones. Well, that would be something like this, where the smallest x can be, the least x can be, is 2. Well, if I think about what I'm looking for here in the table, I kind of want these values, right? I want 2 and larger. And of course, there's a couple ways I can get those. I could easily just add the two probabilities associated with the blue numbers, or I could actually use a CDF command here if I think cleverly. A CDF command will never actually be able to tell me directly the probabilities associated with 2 and 3. And the reason for that, remember, is that a CDF command starts at 0 and I have to tell it where to stop. So I can't actually grab these blue numbers with a CDF. However, you might notice that up here, it's possible for me to grab all the numbers that I'm not interested in with a CDF. This makes CDFs really convenient to pair together with a complement idea. How about I start by saying I'll take all 100% that I have over here, and I will subtract from it all of the x's that I am not interested in, which would be all the x's that are less than or equal to 1. Well, that would be the same thing as specifying that I want to do 1 minus a binom CDF, where n is a 3, p is a 0.25, and can you think where would I need to stop this CDF so that way I grab all the green numbers? Yeah, I'd have to stop at 1. So if I was to do this, the binom CDF will get me the green probabilities, and then I'll take that off of the total, and I'll be left with the blue. So let's see what this would turn into. Going back to the calculator, I could do 1 minus a binom CDF, and I would just change my final value here to 1. Again, I'm getting rid of the values that I don't want, and then I get 0.15625. So 0.15625. And you could indeed confirm that that is going to be the same result as if I had just added these results together originally. So the CDF allows us with some ways to quickly grab lots of values from the table and add them all together. It's important that we understand how both of these calculator commands work. PDF grabs you a single probability in the table across from the number that you specify. And CDF will grab all the probabilities up to a point that you specify and add them all together. Using these two tools collectively will allow us to answer all sorts of questions, and we'll see more examples like that in the next video.